How do we build up our idea of total consumer surplus and total producer surplus? In the previous examples that we took a look at, we only focused in on one individual, one consumer, and one producer. But in any market that we take a look at, we do know that there are more than one individual or more than one producer, so we need to go ahead and add everybody up. So here, this is where we do so. So remember that every point along the demand curve represents an individual's willingness to pay. So here we have a typical supply and demand graph, and we notice that in equilibrium, the price is $6 and the quantity is going to be 6 as well. So here, things that we've talked about in chapter number 3. But we do realize that every point along the demand curve represents an individual's willingness to pay. So based on the idea's allocative efficiency, if there was only one of these units being brought out into the marketplace, the person that values it the most should be the one getting this particular good. And in this case, it's consumer A. Consumer A is willing to pay $11 in order to get the very first unit in this particular market, but is consumer A paying $11? And the answer is no. He's only paying $6 because that's the price in equilibrium in the marketplace. So is consumer A gaining anything from this transaction? Yes, he is. And the difference between this $11 and $6 is exactly consumer A's consumer surplus. So consumer A is gaining $5 from this transaction. And then in order to build up total consumer surplus, we continue on all the way down for every single individual that we have until we reach equilibrium. So if there is a second unit of this good being brought out into the marketplace, consumer B says, hey, I'm willing to pay $10 for this particular good, but remember, consumer B is not actually paying $10 for this good, he's only paying 6, so 10 minus 6, consumer B has a surplus of $4. And then you continue on this entire process until you reach your equilibrium point. So adding up for consumer A, B, C, D, all the way down the line, we get our idea of total consumer surplus, which is going to be this big green triangle on the top right here. It's a sum of all individual consumer surpluses, and more formally, it's going to be the area below the demand curve, so everywhere under our red line right here, under our downward sloping line, but it's going to be above the price. So here, we're taking a look at the equilibrium price, so anywhere above our equilibrium price, below the demand curve, the only area that matches up with this is this big green triangle on top. So here, this is exactly how we're going to define our consumer surplus in equilibrium, and also when things get pushed out of equilibrium. So do be cognizant about this sort of definition right here. So area below the demand curve, constrained by the demand curve, above the price. Suppose that we wanted to go ahead and figure out a specific value for this consumer surplus. Do you think that we could do that? And yes, we can definitely do that because we are dealing with shapes right here. So here, we just identified that this one, this big green thing right here, this big green shape is a triangle. And if you remember from your high school geometry classes, you notice that the area of a triangle is how we can get a specific value for consumer surplus right here. And if you don't remember, there is a formula that goes along for the area of a triangle. We'll go ahead and write that down. Area of a triangle, And the area of a triangle is going to be 1/2 times the base times the height. So it doesn't really matter which one's the base or height, whichever one comes first because it's multiplication. So here, 1/2 times the base times the height. And the base and the height are essentially just going to be the distances that we see on the graphs. So here, as we go ahead and take a look at the base, we go from this point right here all the way down until we hit the other axes. So here, the distance of this base is going to be 6 minus 0. Remember, anytime we hit the origin or the axis, that's a 0. So the distance of the base is 6 minus 0. The height, on the other hand, is going to be the distance from this point to this point right here. So from the demand curve to our price, it's going to be 12 minus 6. And all these numbers are going to have to be provided to you in order for you to get the correct distances. So here we're working with a base of 6. We're also working with a height of 6. And you go ahead and just insert these numbers into our formula. We have 1/2 times the base, which was 6 minus 0. And then the height, which was 12 minus 6. And you want to go ahead and simplify all of this. We'll get 1/2 times 6 times 6. So 36 times 1/2 will give us $18. And this is going to be $18 worth of consumer surplus. So this is only going to be our welfare or efficiency on the consumer side. So how much are consumers actually saving? All the consumers within this particular market. So far, so good. So we go ahead, use the same methodology and steps in order to build up the producer side. So how do we get producer surplus? We follow a very similar pattern. So for producer surplus, remember that the producer side, there is more than one producer, and each of them has their own willingness to sell, which can be seen on the supply curve. So remember, using the same numbers that we have right here, equilibrium price is $6, equilibrium quantity is 6 as well. But producer A is willing to let this product go, the very first unit of this product sell for $2, but because we are in the free market, the product is actually selling for $6, so the producer in this instance is actually gaining $4. So producer A's producer surplus is 6 minus 2, $4. Then we go to the second unit in the marketplace. Producer B is willing to sell the product for $3, just reading it off the supply curve. But remember, it's selling for $6, so producer B has a producer surplus of $3. And once again, we continue on down the line for producer C, D, E, all the way until we hit equilibrium. Once we add up all the producers, we have producer surplus, total producer surplus, which is the sum of all individual producer surpluses. And formally, it's going to be the area above the supply curve and below the price. So above our supply curve, below the equilibrium price in this instance. So this bottom triangle right here is going to be denoted as our producer surplus. So big triangle on top is consumer surplus. Big triangle on bottom is going to be the producer surplus. And this is going to be pretty easy because we are taking a look at things in equilibrium, the single intersection point, but we'll make things a little bit more complex as the chapter goes along. And once again, can we figure out a specific value for this producer surplus? Once again, yes, because we are once again taking a look at a triangle right here. We know the formula now, 1/2 times the base times the height. What is our base? It's going to be 6 minus 0. And our height in this instance is going to be 6 minus 1. So remember, they don't have to be symmetric. You do want to be very careful about these particular distances and the numbers that are being provided to you. So here, producer surplus, the base is 6, the height is 5. Let's go ahead and jot that down. So for producer surplus, it's 1/2 times 6 minus 0, and then it's going to be 6 minus 1. Go ahead, simplify this as much as you can. 1/2 times 6 times 5, so 1/2 times 30 will give us $15 worth of producer surplus, so PS in this instance. And once again, it doesn't really matter that these numbers are not equal, it just tells us a specific value that each of these numbers is going to take. So how much welfare do we have on the consumer side? How much efficiency do we have on the producer side? So far, pretty simple, right? And the last thing that we want to go ahead and do is take a look at how much total surplus we have in the marketplace. And things like we said before are going to be quite simple for us in this instance because we are only dealing with at our market equilibrium. So the single intersection of supply and demand, things are very simple for us because our total surplus is going to be maximized. We have a big triangle for consumer surplus, we have a big triangle for producer surplus, and only at this point are we going to achieve the highest amount of surplus available in the economy. And at the single intersection point, we can consider that we are being market efficient. Markets are efficient when they generate the largest possible amount of net benefits to all parties involved. And how do we calculate out these net benefits? We come to our final idea of efficiency and welfare, which is just going to be the sum of producer and consumer surplus, which is known as total surplus. So total surplus is the measure that we are going to be interested in. The higher the total surplus is, that just tells us that our marketplace is more efficient or there's more welfare within our economy. And total surplus is only going to be maximized when we are in equilibrium, when we have that single intersection point between supply and demand. There's no other point where we're going to be maximizing our total surplus. So the final thing that we can go ahead and do is to go ahead and sum up our consumer surplus and producer surplus to give us our measure of total surplus, which is $18 plus $15, which will give us a cool $33 worth of total surplus. So the sum of consumer surplus and producer surplus will give us total surplus. And this is the number or the measure that we are trying to maximize. Only in equilibrium will we achieve the highest amount of $33 of welfare or efficiency in the marketplace. There's no other point that will generate this amount of welfare. We'll go ahead and do a few more examples of when we of how much efficiency and welfare there is going to be when we're in equilibrium. And then we'll turn our attention to a little bit more of a complex case when we want to see exactly what happens to consumer surplus, producer surplus, and total surplus when we get actually pushed out of equilibrium, when prices go too high, when prices go too low, and we'll see exactly how we can compare this number to those particular situations.